Alright, I'd just like to talk about symmetry a little bit here. And so I've written down a bunch of equations here and that I can talk about symmetry. Now, this has y squared, y no other place in the equation. So if I put in a positive 1 or a negative 1 or a positive 2 or a negative 2, this equation is going to give me the, remember, equations or relationships. If you given one of the variables, you should be able to find the other, or vice versa. And that's what determines what the graph is going to look like, how this produces what one variable in response to whatever the other one is. So if I picked 1 for y or negative 1, this side would still be x squared minus 6 equals 1. It's going to be the same for 1 and negative 1, or for 2 and negative 2 for y. So whatever happens for a positive y, negative y, you get the same thing. So that means it's symmetric with the x-axis. Similarly, since this doesn't care whether x is positive or negative, positive x's and negative x's will produce the same result, means it's symmetric with the y-axis. So this is symmetric with x and y axes. Axes. Okay? This one, it's symmetric. Since it doesn't care about the y, and there's no other y's to mess it up, it's going to be symmetric with the x-axis. But putting positive or negative numbers in for x are going to make a difference on this because it's not squared, so it will make a difference, so it's not symmetric with the y. The next one, this will be symmetric with the y, or with the x-axis because it's y squared. And there's no y's other place. And it looks like it would be symmetric with the y because of the x squared, but because the x is in here, I won't get the same result for positive 1 for x as I would from a negative 1 from x, because that would turn this to a positive 6 instead of negative 6. And so it's not symmetric with the y. This one will... It looks like it would be symmetric with the y, but there's a y over here. That will foul that up. So it's not symmetric with the x-axis. And since it's not squared on the x here, it's not with the y. So it's not symmetric with x or y. This one would be symmetric with the y because it doesn't care whether x is positive or negative, which makes it the same on either side of the y. Symmetric with the y, but not with the x. Now, this one you should recognize as y equals x squared. It's the parabola, but it's moved down 6. So you can see symmetric with the y-axis, same on either side of the y, but not with the x. This one looks like it's symmetric with the x because it doesn't care what the y is, but not with the y. And if I were to graph this, I can move this over and it would look like plus 6. It looks something like this. Okay? Symmetric with the x-axis because it's y squared and only the y squared, not otherwise, and not symmetric with the x or y-axis because there's not x squared. This one. Now I've been kind of dealing just with x squared, but this is the rules also apply for y to the 4th power or to the 6th power. That causes them to be none. Now, odd powers don't cause symmetry. So that's an odd power. So it's not symmetric with the x, but This is an odd power, but it's absolute value. An absolute value doesn't care whether x is positive or negative, so this will be symmetric with a y and not x. And this actually looks like, the absolute value normally looks like this, and it's dropped down 6. So it looks something like that, down 6 on the y-axis. And you can see that it's symmetric with the y-axis because of the absolute value of x, but not with the x. This doesn't care whether y is positive or negative, or x is positive or negative, and so it's symmetric with the x and y. Now, what does this look like? Well, when x is 6, let's say, 1, 2, 3, 4, 5, 6, or negative 6, the absolute value of 6 or negative 6 is 6, minus 6 is 0, and so we'd get intercepts there. If I put in 1 or negative 1, I get, if I put in 1, I get y is, that would be negative 5, and there's no way that happens. So let's put in 7. Absolute value is 7, which 7 minus 6 is 1. So it could be negative or positive 1 in for the y, and so it would be here and here. And if I put in negative 7, absolute value of negative 7 would be 7 minus 6 is 1, and so y could be positive or negative 1, and we're going to get these that look like this. So it's the same on either side of the x-axis and same on either side of the y-axis, symmetric with both. And that's kind of a real brief introduction to symmetry and how to tell from an equation.